All right, so now we want to talk about the energy output of galaxies. So just in the same way that galaxies can have different shapes, galaxies can give off different kinds of radiation into the universe. So one of the first kinds of galaxies that we observed was called radio galaxies. And so radio galaxies give off radio waves. And so there's a picture of what a radio galaxy looks like. And so do you notice you should be able to see the two lobes of the radio galaxy coming out the middle of it. Okay, then they found another kind of galaxy, which was called a Seyfert galaxy. And there are two types, so type 1 and type 2. And so a type 1 Seyfert galaxy primarily gives off ultraviolet and X-rays, and the type 2 gives off infrared light. Okay, then you have another kind of galaxy, which is called a blazar, and blazars primarily give off gamma rays. And then finally, there's a type of galaxy called a quasar. And for the longest time, we didn't exactly know what a quasar was. So one thing that we thought was maybe it was an exploding star. So it was a supernova. Another thing that we thought was that maybe where a black hole takes in all light and all energy, maybe that light and energy spurts out somewhere else in the universe, and that would be a white hole. And so maybe they thought that that's what a quasar was. Well, today we think that quasars are extremely young galaxies, and these quasars are the brightest known objects in the universe. So they give off the most amount of energy of any object in the universe, and they can be up to 2 to 10 billion light years away from us. So that gives us a clue as to what a quasar is. So if a quasar is 2 to 10 billion light years away, then that means the light has been traveling towards us for 2 to 10 billion years. So that means that these objects are today very, very old. But when they first began to shine, they were very young, okay? And quasars emit all different types of radiation. So we've got all of these different kinds of active galaxies. And incidentally, our galaxy is a normal galaxy. So the Milky Way is a normal galaxy, which means it doesn't give off major amounts of radiation. So you have active galaxies that do give off different types of radiation, and then you got other galaxies, which are normal galaxies, which don't give off large amounts of radiation. And our galaxy is a normal galaxy. So we had to come up with an explanation for why would these particular kinds of galaxies be giving off so much energy. And so it's all tied to supermassive black holes. So that in the center of most galaxies is going to be the singularity, which you can't see. Okay, then surrounding the singularity is going to be the black part of the black hole, which again you can't see, because this represents how close light can get to the black hole without falling into it. And then surrounding the black hole is going to be the accretion disk. So this is gases that are circling around the black hole, and eventually their orbits are going to decay and they're going to fall into the black hole. But the closer they get to the black hole, the faster they're going around. So it's like water going down a toilet. So the faster it gets to the center, the faster it's moving. And we know that the faster it moves, it accelerates. And we know that accelerating electrical charges produce electromagnetic radiation. So that this accretion disk is going to be glowing with different kinds of radiation. And then we also know that black holes are going to have a magnetic field. So this represents the magnetic field of this object, and it is going to be very, very concentrated and very, very powerful because this black hole is spinning so very quickly, just like a pulsar. So this black hole is spinning, has a magnetic field, and sometimes this stuff here in the accretion disk can get sucked up into the magnetic field, and it shoots out the magnetic field lines. Okay? Now, depending on how you view this thing, it could represent different kinds of galaxies. Now, this is the black hole that's in the middle of the galaxy. So the galaxy is way, way, way out here. The black hole is very small in comparison. Now, the picture that I've got there shows you the size of the actual galaxy, and then it also shows the size of the black hole that's in the middle of it, and then it also tells you the size of the black hole in terms of millions of suns that's in there. And so if you look at that picture there, it shows you just how big these black holes can get. And it also shows the diameter of the black hole in comparison to the diameter of our solar system. So you might want to take a look at that. The picture there that is off to the right, that's an actual picture of a black hole. So you can see here in the middle of it is the dark spot, and then on either side of it, the orangey part is the accretion disk of it. So let's say, for example, that the Earth is over here. So on Earth, we train our telescopes on this particular galaxy. So we're viewing it from this viewing point, and what we're going to see is these two magnetic fields coming out like this. And so then we're going to see this as being a radio galaxy. On the other hand, if the Earth is up here, and so we train our telescopes on this particular galaxy, and we're now looking down the barrel of this magnetic field, then we're going to see a blazar, a different kind of galaxy. And then if the Earth is over here, and we train our telescopes on this galaxy, and we're looking in this direction, we're going to see yet a different kind of active galaxy. So we think that all of these different kinds of galaxies are really the same galaxy. It's just that we on Earth are looking at it from different viewpoints. So there's an old story about some blind people, and they come across an elephant. And so one of them takes his arms and he wraps them around the leg of the elephant and says, this thing is an oak tree, okay, because it's got this big trunk to it. And then another person grabs a hold of the tail and says, no, this thing is a snake, okay? So depending on your viewpoint, okay, depending on what you were touching, you would think that this one thing, this elephant, is actually multiple things. And so similarly, you've got this one kind of galaxy which is emitting tremendous amounts of energy because of its black hole. Depending on your viewing angle, you would say that it's a different kind of galaxy. So what about the quasars? Okay, now, so the idea about the quasars was that they are very, very far away, which means that they've existed for a very, very long time. So when the light that is reaching us today, that light originated back when the quasar was very young. And so when a galaxy is young, it has a lot of gases to work with. And so as those gases collapse in on the black hole, that produces a lot of energy. But as the galaxy ages, it uses up these gases. And as it uses up these gases, then the energy output of that galaxy begins to get lower and lower and lower until finally it's a normal galaxy. So imagine this, that our galaxy in the past could have been a quasar. It could have been an active galaxy, but today our galaxy has settled down and has become a normal galaxy. Okay, so let's take a break, and when we come back, we're going to talk about galaxy clusters.